It's like I planted you. One of the first things I want to do is make the formula sheet with you guys. First thing I want to do, yes?
Our homework and first just
Okay. Sure.
I know you say like it's by
No. I know. So what I've done in the recent past is I've said the chapter 3 homework is due the day of the next test, not the quiz. But you got to be smart. You should have it basically done before the quiz, because that's the best way to study for the quiz. Just to keep the rule the same, I'll make it due the day of the next test, test 2. But you turn it in. I already gave back some that people turned in, and they got more to study from now. But so it's up to you. But yeah, do enough out of those sections to be ready for the test. Dear God, right? But the homework is officially not due until test 2 for chapter 3. I like it. Okay. Start. I did. Hey. So let's first make this formula sheet. Then I'll see if there's any questions from homework, and then we'll get into general review for probability. So I mean, you've got your basics. All right, what's OR basically? What operation? Addition. I love it. So throughout the course, we're going to see situations where we're going to say blah, 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 or blah, 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 and guess what? We'll be adding those probabilities. I mean, because OR basically means add. Why do I say basically means add? Because there's a little adjustment, dude, that says nobody gets to vote twice, right? Supposedly.
Unless you're...
Yeah, if you're paying attention to the news, you should have weird feelings. Anyway, we won't get into all that. If you're not paying attention to the news, you probably lead a very happy life. And I'm jealous. Probably A given B. This is not a division symbol. This is given. What goes on the bottom of that? Yeah, the given dude. And on the top, the only way to be A is if you're also B, because I know B happened. So the formula makes actual sense. We're not done yet, but what's the only time I'm going to use these formulas? I'm not going to use these formulas if I give you that table. Right? Dear God. Don't use the... Holy shit. If you can count the situation, you do not need the formulas. Will they work? Of course they will. Will they make will they make it harder? Yes, they will. Doesn't mean formulas suck in general. It just means there's situations where it makes it harder because they have to be very general. I hate when people just mess themselves up trying to use a formula in situations where it makes it harder. Of course, what's the formula for probably A and B? It just comes from this guy. Multiply this up. So it is basically multiply the probability of A times the probability of B, but one of them has to be adjusted because the other one will have happened. Okay, I like it. And I think that's it. I mean, there weren't a lot of formulas in chapter 3. Anything else you think should be up there, formula-wise, that I'm forgetting? Okay. I love it. You guys are like, no. In fact, don't even give the quiz, Jeff. It's okay. No, you want more grades. Okay, so that's it. You can actually, if you want to, just add these onto your old formula sheets. Or put this on its own formula sheet so you don't get all confused with z-scores and shit. It's up to you. You can just keep on bringing all your formula sheets with you at every test. Right? Say again? I would kind of recommend putting these by themselves because I know people will get a little bit freaked out when they see S and sigma and mu and all that stuff, and it's not even what this is going to be about. Okay, I like it. So like on the day of the final, you can bring a big stack of formula sheets that you've just created the whole semester. Just make sure none of them are ones that you lost points on. Maybe rewrite those. I like it. And some of you guys are like, how do you use points on a formula sheet? Well, you put more on it than you're supposed to have. That's not fair. So you will lose points for that, so be careful. Okay.
There's a scenario in which you really have to study because you try to is to overdo the formula sheet and lose points. You make up 4 points on the test.
If you want to try it, go ahead. I like a challenge. We'll see how many points you lose. I like it. So anything about that? Anything? What about homework stuff now? Any questions from homework stuff? Or the practice quiz? Yeah.
50 for 3.4. I'm sorry, 3.3.
Number 50?
Yes.
50, okay. Oh, okay. All right, so by the time you get to 50, has everybody got this stuff here? No, not this person, too bad. By the time you get to number 50, you've done the work that you need for this. How do I show that? What would I need to check to see if L and C are independent? What do I need to check? If L and C are independent, what does that mean? One of them happens, but the probability of the other one doesn't change. Please let that make almost too much sense. Right? Should we call that independent? One happens. The other one didn't give a shit. Its probability didn't change. So obviously one did not have effect on the other one. That would be independent. So if the probability of L given C is the same as L was before, not knowing C, here I know C is the same. So C happening did not affect L, or the other way around, whichever one you happen to know. So if they're not equal to each other, these probabilities, they must be dependent, because that would mean that C happening changes the probability that L happens. So sometimes math people pick the worst words to describe things. This is a situation where we pick the exact perfect word, independent, dependent. And then everybody just messes it up. I'm like, damn. Maybe. You cannot say probability of L isn't probability of C. Who gives it? Why would they have to equal each other? You have to see how they interact. And this is the only one that shows how they interact. That probability. And you know, most often I will ask you like A through F, and you've already done the work. So in this problem, you've already done the work. What have you, on number 50, what have you calculated, or what did they just tell you? They told you probably C given L. Right? On number 50 in this. And you know the probability of C, and you can just compare. Are they the same? That's it. But don't just say no, show me why. Anything else from homework or the practice quiz? Did everybody get a copy of the practice quiz? So it's wide open right now. I'm giving a little bit of time for review. We got that quiz next time. Oh, good. I love it. Okay. So let's really investigate. Let's say I tell you that A and B are independent. What can you immediately write down as true? If A and B are independent, you can immediately write down so B happening doesn't affect A happening doesn't affect B. They're independent of each other. So this is the mathematical expression for this English statement. That English statement means these. And remind me, what's the formula for probability of A and B? What's one way to write it? I like it. And what we just say is true about B given A. So how can I rewrite the formula for and?
Probability of A times probability of B.
Bam! I like it. So I know in this problem there's Y's and Z's instead of A's and B's, and I don't care. They're just letters. Who gives a shit? Same reasoning applies. I like it. Now there's a lot of, not a lot, but there's algebra involved here. Why? Because algebra is useful, period. So for example, just to ask you, what if I had x minus 0.11x? That's going to come up in this problem. If you do this correctly. What is that? What's x minus 0.11x? I love you guys. What's in front of the x?
1.
How else can I write 1? So what's a buck minus 11 cents? Yeah, 89 freaking cents. I like it. Right? I'm not saying exactly that's going to show up, but something like that is going to show up if you set this problem up correctly. Is that enough to get you going? Who asked that? Did you ask that? Who asked that question? Did I make it up? Oh. Is that enough to get you going? Or because now you got the y or z for this problem, right? It's y plus z minus probably y and z, and we just talked about how to rewrite that. Then you just throw everything you know in. There's going to be one thing you don't know. It's going to show up twice. Oh, shit. So then algebra takes over and says, combine like terms, get your numbers on the other side. I like it. So the less comfortable you are with algebra, the worse all life will be for you. Period. All right. Maybe. So that was number, what was that? 91, right? Yeah. The chapter 3, number 91. In case you haven't gotten there yet, all of this deals with number 91. So I want you to notice something. When am I allowed to do an and I just multiply the two probabilities together? Only if they're independent. So A and B, I multiply the probabilities together to get the and, only if I know they're independent. What's the only time I can just get an or by just adding the two probabilities together? What's missing? So if they are mutually exclusive, the or is just the straight up addition. So this little thing and this little thing are adjustments for if they're not mutually exclusive or if they're not independent. They are adjustments. You have to understand anything I just said to be able to do problems? No, you can throw shit in there and calculate, it's great, but that's the idea behind it. Anything else to get ready for the quiz next time? We got the practice quiz, get the homework. Yes? Oh, yeah. Okay. So that's that at least one question, right? all right. I'm going to do an example related to that one. Well, anyway, just go with me. It's like, what choice do you have? You got to go with me, so too bad. Let's say I had this. Don't even write this stuff down, okay? Oh my God. Whatever. These are like grades on something. And then I said, all right, 11% of the students made a 30. Shit. If I asked you, what's the probability that a student made more than a 30? Okay, now think about it. If I ask you, what's the probability that a student made more than a 30? Do I have to tell you these stupid things? Why not? I don't have to tell you these stupid things, do I? Why? Because all of these have to add to be 1. So what do all of these have to add to be? 1 minus the 1 it leaves out, always. So the probability of a situation is 1 minus the probability of the opposite situation. When do you want to use that fact? When the opposite situation has a lot less freaking work. Do you want to add all this shit up? Or do you just want to do 1 minus that? I'd rather do 1 minus that. That's a lot less work. Is it wrong to add all this stuff up if I gave it to you? No. It's just kind of silly. If you want to waste time, feel free. Maybe. So, specifically, when I ask you a problem where I'm counting things, like number of TVs. In this problem, it was number of people that disliked the plan, right? I'm counting things. So what's the smallest amount it could be? If I take a group of people and I count how many people dislike the plan, what's the least number of people that could dislike it? 0. And what's the most? Whatever the total number is. Everybody. Right? So in this case, I'm going to have 0 through, I think it was 4 people, right? 3. So when I ask you, what's the probability of at least 1? At least 1. What's the only thing that leaves out? None. So the probability of at least 1 equals 1 minus the probability of none. And in this case, that kicks a lot of ass. Because there's a lot of work involved. If it's 1, maybe it's the first one, or the second one, or the third one. If it's 2, maybe it's the first 2, or the last 2, or the first one and the last one. Maybe it's all 3. Oh shit, you got to add all that shit together. I'd rather do probability of none, 1 minus that, done, next, maybe. So in this problem, let's see. On part B, I asked you the probability that all 3 dislike the plan. So that's like nobody likes it, right? That's part B. 3B. So number 3, what's probably somebody who likes the plan? Just in general, in number 3. What's probably they dislike the plan? Let me start there. Because that's what I tell you. Is everybody looking at the probability practice quiz? Number 3, what's the probability that somebody dislikes the plan? 33%. I like it. So it's probably somebody who likes it. 67.
What's the odds of them having no idea what the plan was all about?
Well, to be honest, I should put up here dislike, not dislike. And that captures every other opinion. You with me? But just for the purposes of making this easier to write, I'm going to call it dislike and like. With me? Polar opposites. Everything can be broken into 2 groups. This group and the opposite of that group.
X and not X.
X and not X. I love it. Okay. You guys with this so far? I mean, that's just straight up from what I tell you. They're probably somebody likes it is 33%. Dislike it. Probably they like it, then it's 67%. Blah, blah, blah. So now, probably that all 3 dislike it. All 3 dislike the plan. How do I calculate that? So I've got 3 people. The way to say this in English is the first person dislikes it, and the second person dislikes it, and the third person dislikes it. So what am I going to do with those three probabilities? Multiply it, because and means basically multiply. This is that hangman thing. I've got 3 spots. What's going to go in each spot? They all 3 have to dislike it. So what's the number? 0.33.
The 0.33, 0.33.
Isn't that just 0.33 to the third power? Right. The same thing. So just multiply those together. I love you guys. Some of you guys look at me like you lost me at good morning. What the shit? So I am just doing part B right now. The probability that all 3 dislike it. What is another way to say that? All 3 don't like it, so that means that none of them like it, right? That's another way to say that. So what is 0.33 times 0.33?
0.0359.
Sure. Now, coming back to the idea we just spoke about. 3C says, what's the probability that at least one likes it? Well, that equals 1 minus the probability that what? What's the opposite of at least one likes it? What's the opposite of at least one person in here likes it? Nobody likes it. And what did we just calculate on 3B? We just calculated this shit, didn't we? You'll start to realize I like to do that. Part of the problem will be something that you're going to use later in the problem. So now you just got to do 1 minus 0.0359. So the general idea I'm using is the probability of something is 1 minus the probability of the opposite. When do I use this idea? When this has less work. That kind of makes sense. You can either do this directly, or you could do the opposite, subtract from this. Got a lot less work. In fact, I already freaking did it. So it's got 0 work. So hopeful. All right. Anything else from the quiz, the practice quiz, or the homework stuff? Let me give you, oh, yes. For A? Yeah, what does independent mean? How do I check it again? For C, okay. Oh, well, what does mutually exclusive mean? What's got to be true for them to be mutually exclusive? And you're like, that's what I'm asking you, bud. To be mutually exclusive, the probability of A and B must be 0. Kind of makes sense. If they mutually exclude each other, the probability they both happen is 0. Again, the more you understand the idea, the easier it is to interpret these questions. And then at that point, you've on part B, you calculated the probability of A and B. So then you can just reference that. If it's 0, yes. If it's not 0, no. All right, so let me give you the answer key. This might spur some more questions. My answers are supposed to be in red, but I didn't realize I ran out of colored ink to do that.
answer, and I took it out further than that. So on the actual quiz, if I do that wrong,
Which one are we talking about?
number 3,
3, which part?
see, you just stopped it at 0.33. I took it out to 0.333.
But be careful, 33% is not 0.3333. Right? If I said 1/3 of people, that would be 0.3333. 33% is 0.33. Right? Just like 28% would be 0.28. Yeah. All right. So any questions from that? There. By the way, I'm going to send out another email reminder. I have about 17 people who never did fill out that little survey. I really want that data. I want it. I'm a data vampire, so I create quizzes and stuff, and the larger the sample, the better things are. So I'll send that out. If you didn't do it, do it. It's still fine if you do it now.
Why'd you go up so much? Jeez.
What's that?
Use them for next semester.
Sometimes, yeah. Like I already used stuff from last semester on something before because they didn't have enough of your stuff. Anyway, that's just a side note. So anything from chapter 3 still before we get into chapter 4? Dudular. Cool. I like that. That's not normal for me. All right. So let me ask you guys this. There's a lot of ways to give somebody data, believe it or not. The way we've worked with it so far is I just give you a list of data. 2, 8, 10, 13, blah, blah, blah. Right? When I give you data, what's the 2 most important things to calculate from that data? The mean and the standard deviation. What's the middle? And what's the spread? Right? Those 2 numbers summarize the data really well. And then we can make z-scores and do all this other shit with it. Cool? Yes? So, anytime we get a different way to get data, we're going to have a different formula for the mean and the standard deviation based on that new way to get data. What I'm about to do, you really make it clear what I'm about to do. I'm about to show why the formulas work that we use to calculate the mean and standard deviation in this new form by showing the relationship between the way we did it before and the way it's going to be now. So the work I'm about to do is nothing you will ever actually have to do until we get to the end and I show you the shortcut about how to get it. All right, maybe. I do this all the time. There's a derivation and then there's what we actually do. So, in the olden days, I would have given you a list of data like this. Oh, well, let's see. What is that? 4, 5, 6, 7, 8. I like it. Yeah. I'm going to do some weird shit with this. Some shit you would never do because you're like, why would I do that shit? But it's going to lead into the way to handle a list of 18 million data points quickly. Right? That sounds like a good trade-off. How many data points is this? 10. So there will be easier ways to do this one, but it's an easy situation to show you why the math works. Okay, I like it. I have to do these little precursor statements because I always have, what are we doing shit like, oh my God. All right. So how would I used to have done the mean? This is my little population. How would I have done the mean before? Add them all up. If I add them all up, let's be smart about it. So I got like 3 1s, right? 3 1s plus 1 2 plus 4 3s plus 2/4, and then you divide by 10. I like it. So on the side, I'm going to put what the answer is. And then here, I'm going to keep going and do some weird-ass shit. And then we'll see how it connects. So what would we actually get? So here's what we actually get before. We should get the same answer this other way. But so what do we get? We have 3, 5, 17, 25? Neato. So that would be the mean. Is everybody cool with that? Yes? Yes? Okay. I like it. So, here's another way to look at this, right? Couldn't I look at it this way? 3/10 of the data was 1. 1/10 of the data was 2. 4/10 of the data was 3. And 2/10 of the data was 4. So mathematically, this is just saying, let me divide by 10 and then add instead of add and then divide by 10, right? You guys kind of with me? It doesn't break order operations because I'm dividing everything by 10. Okay, maybe? So not a big deal, right? You're all like, ooh, Jeff, wow, look at you go. But let's see, what's 3/10 times 1? 3/10 is 0.3. 1/10 times 2, so 2/10, 0.2. This is 12/10, so 1.2, and this is 8/10, so 0.8. And then what do I get? Remarkably enough, I get 2.5. Just because I reorganize the math doesn't mean the answers can suddenly be different. So on that level, it's like, ooh, we already knew the answer, Jeff. And this is where I know I still have a student saying, why are we doing this shit? We already get the answer. Because now, the way they're going to give me the data will be like this. So now I want to make the connection between the way we're going to see the data and how it connects to this work here. We've already seen stuff like this. I've already written these kind of table up here a few times to get you ready for this. Where are we at? So what this means is 30% of the data was 1s. 10% were 2s, 40% were 3s, so forth, right? Yes, yes? So if I only gave you this table, do you know how many people I talked to? No. If I talked to 10 people, then 3 of them said 1, but I could have talked to 10,000 people, and then 3,000 of them said 1. You kind of with me? A little bit? So what is it that I'm doing here on this row here? What am I doing with those two things? 1/10 times 2, 4/10 times 3. I'm just multiplying these together. So what would this column be called? X times P of X, 11. So the probability, those probabilities, those percentages are called weights. So is everything equally weighted? No, they're not equally weighted. I love it. So I have to multiply the weight by the value.
Which one's the weight and which one's the value?
The weight, and these are the data values, right? So then I get 1 times 0.3 is 0.3, 2 times 0.1 is 0.2, 3 times 0.4 is 1.2, 4 times 0.2 is 0.8. And then you just add those up. So what's the formula for the mean now in this setup for x, p of x tables? What's the formula for the mean? What did I do to get the mean? Sum, which is the sigma symbol. What did I add up? These. So that is the formula for the mean if I give you x, p of x table. This is also known as a probability distribution. That's awesome. It looks a lot like our relative frequency distribution, but now it's a probability distribution. You guys enjoy this? Let's see. All right, now, let me see if I can. I've got a, you know me, I've got a handout with a whole worked out example, and then the other side is going to be you tackling a problem on your own, right? What do I still have to calculate that's important? We got the mean. Standard deviation. I love it. So recall that the formula for the standard deviation was this beautiful thing, right? You with me? A little bit? And in fact, let me show you, let me really get you thinking about this. The formula for the mean used to be this. You with me? And I'm not fundamentally doing something different, I'm just reorganizing the math. So what's the formula for the mean now if I give you x, p of x? It's this. What looks like it's missing here? What's the main thing that looks like it's missing? The n. But what's on the bottom of any probability? What's on the bottom of the probability? The total number, the freaking n is in there. It's in there. Like ragu, that's old reference. So, you guys, I really want you to see that. Kicks ass. The formula for the mean should be divided by n, but p of x has the over n built in. So it's the same stupid formula. It has to be. It's just a reorganization of this formula to match the way they gave it to me, so I have a quicker way to get it. Okay, I like it. Maybe. So, yes?
Well, we can go with n or n minus 1 for population.
So what did I say at the beginning? This was a population. It's a small population, but a population could be one person, right? So it's a population. And as a side note, since the bottom of probability has n, it pretty much has to be assumed that it is a population we're talking about, because it doesn't have n minus 1 in it. It's got n in it. I like it. Maybe. So, to calculate the mean, I had to multiply the values by their weights before I added them up. So to calculate I missed my squared. To calculate the variance, I used to have to add these up and then divide by n. Here I had to add these up and divide by n. I'm going to do something very similar. I'm going to have a row of these, and I got to multiply by the probability. I'm going to multiply by the weight the same way. The same way we did with the x values to get the mean. I love you guys. That look on your face is precious. Sorry. So we're not going to do this. Let me see. Let me try desperately to get you. Don't write this. All right? Don't write this. Because I could have a whole other column of x minus mu, and then I have x minus mu squared, and then I have x minus mu squared times p of x, and then I add all these up. So I'm going to show you a way to have only one more column to add on to this. That's much quicker than any of that shit. So don't write that down. Let me take that away. Go. This is going to involve a little bit of algebra. So, here's what this formula is going to be now. It's going to be this times p of x. Well, let's work with this a little bit. Let's kind of rewrite this in a better form. Because that's going to be a lot of freaking work. I want to see if there's a way I can just have one more column and get to the answer quicker. Put your algebra brain in. What would your algebra brain think about this piece? When you see that, what is it that you could just hear your algebra teacher saying to do? X minus mu squared. What would you do with that? You can't square root it. Well,
Double it.
huh?
Double it? Like multiply?
Write it twice and then FOIL. I love it. I won't talk about how much I hate FOIL, but too bad. Anyways, just repeated distribution, but I won't. So take a minute. Go ahead and FOIL that out. FOIL that bad boy out. I'm tired. You guys do something. Just focus on this dude right there. Just FOIL him out. Oh, you guys are excited now. We're not going to do a lot with this. We're going to do like the first couple steps, and then I'll show you the result.